All right, so on the front page, it has to do with the roses. We wrote this down wrong yesterday. I got ahead of myself. I should have looked at my notes before I wrote this down. Roses for the period. If n is odd, the period is pi. If n is odd, the period is pi. If n is even, the period is 2 pi. We accidentally flipped that around the other way yesterday. I had them backwards on the roses. Right here. If n is odd, there are n petals and it has a period of pi. Please make that correction. If n is even, there are 2 n petals and the period is 2 pi. Like I said, on the notes yesterday, I accidentally got those reversed. Please make that correction on your page. Because when we are doing the table of values, we only need to take it out as far as the period is. So it's really important that we know what our period is here. All right. And then I want to go finish up number 2. We'd gotten this far yesterday on number 2. So we are ready to substitute in 7 pi over 6. So we have r equals 1 minus 2 sine, thank you, 7 pi over 6. What is the sine of 7 pi over 6? What is the sine value of 7 pi over 6? Negative 1/2. So I have r equals 1 minus 2 times negative 1/2. Negative 2 times negative 1/2 is what? Positive 1. So I end up with an r value of 2 here. So 7 pi over 6, that's this right here. We're going to follow that one out further into the third quadrant, out to 2, right here. Five pi over 4. I have r equals 1 minus 2 sine of 5 pi over 4. What is the sine of 5 pi over 4? Negative radical 2 over 2. So this becomes 1 plus radical 2, which is approximately what? What'd you say? 2.4. R is approximately 2.4. So here's my angle line for 5 pi over 4. I want to take that out to 2.4, right about here. Four pi over 3. What is sine of 4 pi over 3? What is sine of 4 pi over 3? Negative square root of 3 over 2. So when I multiply that by negative 2, I end up with 1 plus radical 3. 1 plus radical 3 is approximately what? One plus radical 3 is approximately how big? How much? Right about 2.7. So 2.7, we're getting really close to that third radius line there. 3 pi over 2. What's sine of 3 pi over 2? -1, and I'm going to multiply that by -2. So what is my output for r when I use 3 pi over 2 as my input? For this one right here, it is going to be the whole number 3. When we have an input of 5 pi over 3, what is our output going to be? What's our r value? 2.7. Because the sine value for 4 pi over 3 is exactly as the sine value for 5 pi over 3. So we're going to see a repeated value here. What about when we use 7 pi over 4 as our theta value? 2.4. So right about here. 11 pi over 6. 2. And 2 pi. 1. This is one of the limicons with an inner loop. All right. Go ahead and turn the page. And look at the equation here. Tell me what kind of a graph we're going to make on number 3. A spiral. How do you know? No cosine, no sine. This is going to make a spiral. What's the period on a spiral? No period. So we just need to continue substituting in values for theta until we get output values that are too big to fit on the graph. What's the largest r value we have on our graph? 5. So 5 or -5, that's as far as I can take it. All right, so I'm going to take this table, since I don't know how many values for theta I need. I'm going to split each of these cells in half. So I've got 0 here. So when I substitute that in, r equals -0. Well, that doesn't really make any sense. So my output would just be 0. I'm going to have a point at the origin. 0, 0. What's the next angle value I should have? Pi over 6. We're going to take that and substitute it in. R equals -, and then I put in my value for theta. -pi over 6 is the exact output, but I don't know where that is on my graph. Can you guys pop that into your calculators and give me a decimal approximation? I know it's going to be a negative. -0.52. So here's my pi over 6 line. If it's negative, am I going to move further into the first quadrant? No, I want to go backwards into the third quadrant. So it's going to be right about here. What's our next angle measurement we're going to substitute in? pi over 4. So I substitute that in. R is negative pi over 4, which is about how big?
0.8478.
Yep. Don't forget the negative on the beginning, because negative was part of our rule here. Negative 0.78. So again, I need to move backwards. It's getting closer to the 1, but still not there yet. And then we have pi over 3. What's our output there?
Negative 1.04.
Negative 1.04. So now we're back here. I'm starting to see this spiral take shape right here. What about pi over 2? How much? 1.5. Don't forget your negative. It's about negative 1.5. So now all of a sudden we're out here. What about 2 pi over 3? You said negative 2.1? Yep. So right about here. Three pi over 4. Negative 2.4. 1, 2, so right about here. 5 pi over 6. Negative 2.6. Oops. I just realized I messed this one up. There we go. There we go. What about pi? Please, nobody grab your calculators for this. Negative 3.14. Oh, goodness sakes. Seven pi over 6. Negative 3.7. Five pi over 4. Negative 3.9. Getting really close to that 4. 4 pi over 3. Negative 4.2. So just a little bit past. 3 pi over 2. Negative 4.7. So right about here. We're getting really close to as far as we can take it on our graph. See, after 3 pi over 2, we would have 5 pi over 3. Negative 5.2. So just barely off of our graph here. So I'm going to put an arrow on the end because our spiral would keep going. All of the other graphs that we've looked at have doubled back on themselves, but the spirals do not. The spirals keep going and going and going. What kind of graph is number 4? It is a circle. What's the period for all of our circles? What'd you say? 1 pi, yes. I want you guys to practice doing this graph on your own. So you need to go from 0 to pi, find your R values, and plot your points. Right. When we use 0 as our theta value, what's the R value? 0. Because sine of 0 is 0. Sine of cosine is 1. So if this was cosine, it would be 2. But because it's a sine value, it is 0. What about pi over 6? What's our output? What'd you say? I got 1 precisely. Because what's the sine of pi over 6? 1/2. 2 times 1/2 is 1. Pi over 4. 1.4. This one comes out to be exactly the square root of 2, which is about 1.4. So right about here. What about pi over 3? About 1.7. Exact value would be radical 3. That's what you should have gotten. And then to be able to graph that 1.7. I want your decimal values, so I should probably switch those around. I want to see the decimal values because I want to see what it is that you're using to plot your points. Pi over 2. 2. So right up here. 2 pi over 3. Same thing as pi over 3 because the sign values for pi over 3 and 2 pi over 3 are exactly the same. 3 pi over 4? Three pi over 4 is the same as which one? Same as pi over 4. So radical 2, or approximately 1.4. 5 pi over 6. 1. And pi. 0. Hopefully you guys are able to see this circle take shape on your graph as you plot those points. Let's turn the page. Yes, sir.
Don't like flowers, don't their petals like follow the spiral of Archimedes, something like that? Like they have like a mathematical equation like to the shaping, like the way the petals are. Something like
Oh, are you talking about like flowers in nature?
yeah.
Yeah, a lot of times they'll follow like a spiral of Archimedes basic shape, yes. Yes, yes. What kind of shape are we doing on number 5? What is this one? The lemniscate. How do you know? Our R value is squared. What did we say the period was on the lemniscates? 2 pi. Are you sure? It is just pi.
Oh,
That's okay.
I took the 50-50.
You took a 50-50 shot and lost. The reason I keep pressing you guys about the period is because if the period is pi, we don't have to go all the way out to 2 pi. Less work. If the period is just pi, if you take it out to 2 pi, you're just going to repeat values and you're going to trace back over your drawing. All right, so let's get our values in here up to pi. So 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. I already heard some interesting conversations. I love it. So what is it that's special about the lemniscates that you can recognize them right at the beginning? The r squared. So as we substitute in values, we're going to find r squared. So how many output values will we get for each theta? 2, because we're going to have to take the square root. So we'll have both the positive and the negative. So I have 4 cosine of 2 times 0. What's 2 times 0?
0.
0. What is the cosine of 0? 1. So I get r squared equals 4. So what is r? Plus or minus 2. So right here and right here. For pi over 6, I have r squared equals 4 cosine of 2 times pi over 6. What's 2 times pi over 6? Pi over 3. What is the cosine of pi over 3? So r squared equals 4 times 1/2. What's half of 4? 2. So what is r? R is plus or minus the square root of 2. And square root of 2 is about how much? About 1.4. So plus or minus 1.4. So right here, and I have to trace it backwards. When I put pi over 4 in, I'm going to have to scoot all of this stuff a little bit so that I got some room here. I do 2 times pi over 4. What's 2 times pi over 4? Pi over 2. What's cosine of pi over 2? 0. So 4 times the cosine of pi over 2, I end up with r squared equals 0. So my output here is 0. I've got a point right on the origin. Two times pi over 3 is 2 pi over 3, right? What type of number is the cosine of 2 pi over 3? It's a negative. And if I multiply it by 4, it's still a negative, right? Can I do the square root of a negative? We can do imaginaries, but I don't have anywhere on this graph for imaginaries. So this is undefined for this graph. I'm not going to have a point there. What about with pi over 2? Same problem shows up. Because when I do 2 times pi over 2, I get cosine of pi. Cosine of pi is negative 1. I can't do the square root of a negative, so I have another undefined value here. 2 times 2 pi over 3. What's 2 times 2 pi over 3? 4 pi over 3. What's cosine of 4 pi over 3? Negative 1/2. So I'm going to get another negative that I need to square root. Undefined again. Well, those 3 were nice and easy. Is the next one undefined? Why not?
0.
It's 0. Why is it 0? Cosine of pi over 2 is 0. 3 pi over 4 times 2 is 3 pi over 2. And so I get a 0 here. What about with 5 pi over 6? Square root of 2, so plus or minus 1.4. So right here, follow that backwards to right here. And what about with pi? Plus or minus 2. What do the lemniscates look like? They look like a bow tie or an infinity symbol. If it's a cosine, looks like a bow tie on straight. If it's sine, it's a bow tie on crooked. I would like you guys to work on number 6. I want you to identify what kind of graph it is, what's the period for that graph, fill in your table, and plot your points. All right. You should have identified this as a limison. This was one of the special limisons that is called a cardioid. It had a period of 2 pi. And we'll do those last 2 graphing problems tomorrow because I want to get your tests back to you.